Now more problems on eigenvalues and eigenvectors and Cayley-Hamilton theorem. Let us take a matrix A, 0, 1, minus 1, 0. The trace of this matrix, trace A, comes out to be lambda 1 plus lambda 2 is equal to 0, and the determinant of A, that is lambda 1, lambda 2, comes out to be plus 1. So now lambda square minus trace of A into lambda plus determinant A is equal to 0. So lambda square minus this is 0, 0 lambda plus 1 equal to 0. This gives me lambda square plus 1 equal to 0. That means lambda comes out to be plus minus iota. So I've got two values. One is plus iota, the other is minus iota. Now for finding the eigenvectors, now we will find eigenvectors. Let me write down what I'm going to do. Let me write eigenvectors. We are going to find eigenvectors. We found out the eigenvalues. We found out eigenvalues. What was that? Lambda equal to I and lambda equal to minus I. These were the eigenvalues. Eigenvalues. Now we are going to find eigenvector corresponding to for lambda equal to I. Now my equation is A minus lambda I into x equal to 0. Now A is what? A is 0, 1, minus 1, 0. Then I have your, and for I, minus I, 1, 0, 0, 1. And then let me write it like this. This is x1, x2. And then this comes out to be 0, 0. Now let us see one thing. This is 0 minus, this is minus I, 1. Then minus 1, minus I. I hope you're getting this. Minus I, minus 1 and this. Now you see one thing. What I do is this. See, this is x1, x2, 0, 0. Now see one thing. I take a row operation. I do one thing. I multiply, I replace R2 by R2 minus plus I plus I R1. So what I get is minus I plus 1, and this is minus I, this is minus I into I is plus 1 and minus 1, that is 0, and this is plus I now and this is minus I, and this will give me 0, this will be x1, x2, and this will be 0, 0. See what I did. I multiplied this first row. See, I'm multiplying, I'm doing it in the rough. See, in the first row, what I'm doing, I'm multiplying with I minus I square, and this will be I. So this will be minus 1 and I. Now the second row, this is the first row after multiplication. And the second row is minus 1 and minus I. What I am doing is, I am adding, this is plus 1, sorry, and this is minus 1. I'm just adding them up. See again, wait a minute, see again what I have done. It is bit, you don't get confused. See, in the first row, this is my first row, I have multiplied with I. So what will it become? Minus I square and I. This will become minus 1 and hence this will become plus 1 and this will become I. The second row is minus 1 and minus I. I am adding them, so this is 0. I hope now you have understood it clearly. That why this and this are 0. This was the rough. This was the rough. Now I can rub it out. I can rub it out. No problem. Now you have, see this. Minus I x1 plus x2 equal to 0. So you take x1 to be 1 and you take x2 to be plus I. So your first vector is 1 comma I, because if you put 1 here, it will become minus I and plus I, which will give you 0. The reason is here. The reason is here. Though this reason has to be written in the rough. Wait, this has to be written in the rough. Wait, let me shift it to the rough side. This is the rough side. Okay, I'm keeping it there for your rough. This is your rough. Now, the next point is for lambda. This was the eigenvector. Wait, this is the eigenvector for lambda equal to I. You see, lambda equal to I. Now I need to find the eigenvector for lambda equal to minus I. For lambda equal to minus I. Again the same formula. Now you will write this as it is. Now this was 0, 0, and this was 1, minus 1 and 0, with now this being minus and here a minus, so this will become plus I, 1, 0, 0, 1, and the whole thing with x1, x2, and this will be 0, 0. So now you will have, see, this will be I1, minus 1 and I. I hope you are getting it. Now the thing is, see, this is x1, x2. Again, as in the previous method, see, what I will do, this is 0, 0. I can do one thing. Either I can multiply the upper portion, the upper row by minus I, or I can do a multiply with plus I, the second row, and add to the first row. That can also be done the way you want to do. See, what I am doing is, R2 I am replacing with R2, then plus, no, let it be minus, this will be minus I R1. See what happens. When I multiply the first row by minus I, this becomes minus I square minus I. So this becomes, so this is, I'm copying this matrix. This becomes like this, and this becomes like this, and this becomes like this, and this becomes this, and this becomes this. So now when I am adding them, basically this is minus. Let me rewrite it more clearly. Wait. This is plus minus I of R1 actually. So this becomes I1, 0, 0, x1, x2, and this becomes 0, 0. So now you have I x1 plus x2 equal to 0. So you can write this as I into, you can take x1 as, you can take x1, you can take x1 as your I, and x2 as plus 1. You can do this, or you can do x1 equal to minus 1, x2 equal to I. So it's your choice. If you take this, you will get this vector. You will get this vector. You will get I and 1. And if you choose this, your x2 will be minus 1 and I. It's just similarly you can, because vectors are linearly independent but not distinct. Vectors are, similarly you can do for this also. Similarly you can do for this also. You can take, or you can take, here you can take x1 as I, and this will become my, and x2 as minus 1. So that can also be done. I have chosen this one. I have chosen this one. So I got this. And had I taken this one, then I would have got x1 vector, another x1 vector as, this is I comma minus 1. I comma minus 1. The way you want to do it. They are not unique. They are linearly independent. That's the point. They are linearly independent, right? Now with this we'll come to another example on complex matrices. Now see another example on complex matrices. I'm taking a matrix. Let's say A. I have a habit of taking A only. You can take B, C, whatever you want to do. 1 minus 1, and you have got 2 minus 1. Now here the trace of A is lambda 1 plus lambda 2, that is again 0, and the determinant of A is lambda 1 lambda 2 is equal to, this is minus 1 plus 2, minus 1 plus 2, that is plus 1. So again here the equation is lambda square minus trace A lambda, trace A lambda plus determinant A is equal to 0. Now you put the values, lambda square minus trace 0 lambda plus 1 equal to 0. You get lambda square is again plus 1 equal to 0. As usually I get plus iota and minus iota, the eigenvalues. The eigenvalues. Now you need to find the eigenvectors. Now you need to find the eigenvectors for this matrix. So you have for lambda equal to I, first for the first case. So you have A minus lambda. You must always write this formula every time you try to find the eigenvectors. So what is your A? A is your 1 minus 1 and 2 minus 1 with minus I 1 0 0 1 and a whole bracket x1 x2. With this you have got 0 0. Now let's try to write it down. See, 1 minus I minus 1 2 and then minus 1 plus I. You can see this. You can see this. X1, X2 is 0, 0. Now see one thing. You can do, you have to make this two, do one thing. Very simple. You can see one thing, the determinant of this matrix will come out to be 0 if you cross multiply. So what you do is that you multiply this row by I plus 1. See, how did I understand that I have to multiply this I plus 1 is that I cross multiplied this and I found, see, if I cross multiply, I'll get minus 2 and plus 2, which will be 0. If you cross multiply, you take the determinant of this. If you take the determinant, you will get this. So that means on the first row, I need to multiply with this. This is the clever hint I got. Wait a minute. So what I do is that, wait, let me rub all this. Let me rub all this. Now you have to do, wait, let me rub this also. Now you have to do is R2 is to be replaced with R2. You have to replace with R2 and then minus 1 plus I R1. So if you do this, this first row, see I'm doing in the first row will become minus 2 and this will become minus 1 plus I. And in the second row, you already have this. You already have this. So just you have to subtract and this will become 0. That's the way you have to do it. So this is 1 plus I, sorry, this is 1 minus I into minus 1 and 2 and then this is, see, this is 0, sorry, this is 0 and this is 0. You have x1 x2 and then you have got 0 0. See, determinant has to be 0 of this matrix, otherwise you will get a trivial solution being a homogeneous equation. The determinant has to be, see one observation, the determinant of this matrix, determinant of this matrix, determinant of this matrix, let us call it B, it has to be 0. Otherwise, you will get trivial solution, that is unique solution, and that is not a vector at all. So the determinant has to be 0. It cannot be non-zero. I am repeating again. That is, determinant of B has to be 0. Otherwise, you will have trivial solution. If determinant, let us consider this as B, the whole matrix as B, the determinant B is non-zero, the only solution will be this, x1, x2 is 0, and this is a trivial solution and trivial eigenvector. That means the eigenvector is 0, 0, null vector, which is of no use. So the determinant has to be 0 of this type of a matrix. Let's rub this all now. Now, the thing is this, now wait a minute, this is 0. So now we will write down the equation 1 minus I and x1 plus minus x2 equal to 0. What I do is that I take x1 as 1 and I take x2 as 1 minus I. So the first vector is, I got the first vector as 1 and 1 minus I as my first vector for lambda equal to I. Now for lambda equal to minus I, for lambda equal to minus I will have to do A minus lambda I x equal to 0. So A minus A is your, the same vector, A is your vector 1 minus 1 and 2, this is minus 1, and now this is minus I into minus I. Wait a minute. Let me rub this. Wait. Minus of minus I, and this is 1 0 0 1, and this is x1 x2. This is 0 0. Now see, this is going to be 1 plus, this is going to become plus I, this is minus 1, 2 plus I, 2, and then this is going to be minus 1 plus I. Again, you can see very easily you can see, if I take the determinant, this determinant, see what will come. Let me do it in the rough. Minus 1 is, this is like a plus b and a minus b. So you will have I square minus 1 and plus 2. So this will become minus 1 plus 2 and again 0. See, the determinant has to come out to be 0. If the determinant doesn't come out to be 0, that means the only solution for x1 and x2 is 0. That is the trivial solution which is not acceptable, because eigenvectors, we consider those eigenvectors only for which it is a non-zero eigenvector. At least one of the component is non-zero. See, that means x1 is 0 or x2 is 0, not both together. Wait a minute, let me rewrite. Either x1 is 0 or x2 is 0, not both together. Then it will become a trivial solution. So that is not acceptable because eigenvectors are non-zeros. Now what I do is that, again that same clever trick I use. I multiply R2, I replace R2 by R2. Now if I do this multiplication, this will become minus 1 and this will become minus 2. So what I do is that plus minus 1 plus I, R1 I do. See, if I do this, so what I will get, this will become 1 plus I minus 1. This will become 0 because this will now become minus 1, and this will become minus 1, that is minus 2 and plus 2 here. So this will give me 0. And here it will become plus 1 and minus I when added with this will give me 0. I hope you've understood how this has been done. You can cross multiply and you can check it. This is 2. Wait a minute. This is 2. Now with this 0, now with this 0, this x1 and x2 is now 0 0. So now 1 plus I, x1 minus x2 is 0. You can take this way the vector. You can take x1 as 1 and x2 as 1 plus I. That would do the job for you. So the eigenvector for this x2 is 1 comma 1 plus I. So I got two eigenvectors for the system. I did this complex one for you guys. This complex one. I did two complex problems so that you get complex eigenvectors and eigenvalues. Now see the cases. Case number 1. When all eigenvalues are distinct. All eigenvalues are distinct. Distinct means they are all different. That is lambda 1 not equal to lambda 2 not. I'm doing it for 3. You can do it for 2 cross 2. I'm doing it for 3 cross 3. Now, let me take this example. This would be a better one. Let me take this one, an easier one also, or you can take a tough one, no problem. I'm taking a little tough one for you guys so that you can understand. Let me take this example. Let me have a matrix A. Now 8 minus 6, 2, and then you have minus 6, 7, minus 4, and then 2, minus 4 and 3. Now I'm taking the determinant of this matrix. The trace of this matrix is, what is the trace? That comes out to be around 18, because this is 7 and 5, 8 is 15 and plus 3. 8, 7 and 3, that is 8 plus 7 plus 3, and this is equal to 18. Trace of A, and this is lambda 1, lambda 2, lambda 3. Never consider that lambda 1 is 8 and lambda 2 is 7 and lambda 3 is, never do that. Never take this way. Never take this. Never do this mistake that this is 3. Never do this. Oh, never consider, sorry, never consider, wait a minute. Never consider, let me write down. Never consider lambda 1 is 8 and lambda 2 is 7 and lambda 3 is 3. Do not do this. No, do not do this. Never do this. Now let me rub this now. This is of no use for you. I've told you what's the idea. Now let's find out the determinant. The determinant of A is nothing but lambda 1, lambda 2, lambda 3. Now if I take the determinant, I'm giving you directly the answer. The answer comes out to be around, let's say, 45. Comes out to be around, let me find it out for you. This comes out to be determinant. The determinant comes out to be, let's say, let's find it out. 8. 7 3s are 21. Let me rub them. Sorry, let me rub them, these sticks. Otherwise, 8. And then 7 3s are 21 plus 16 minus 16 plus 6. Now you have is 3 6 are minus 18 plus 8. 3 6 are minus 18 plus 8. So now you will have, wait a minute, you will have a determinant 0, I hope so. I have done this problem, I'm remembering that. That is 3 6 are 18 and plus 8 and then plus 2, 24 minus 14. This is 8 into 5 minus 6 into plus 6 into 10 minus 10 and then 2 into 10. This comes out to be, say, 40. This is minus 10. Wait, let me write it properly. Minus 10. This is minus 10. 40 plus minus 60 plus 20, you get a 0. You get a 0. So now I know the equation. I know all that equation. I'm not rewriting. I have lambda's cube minus trace A. Trace A is 18 lambda. I have got 18 lambda square. Now plus A11. A11 is, let me find out. A11 is how much? A11 is hiding 21. 21 minus 16. I'm doing it directly. 21 minus 16 is 5. 21 minus 16 is 5. A22, that is 24 minus 4, that is 20. A33, I'm doing it directly, that is 7 is a 56 minus 12. 56 minus 12, 56, and is a 56 minus 12 is around 4 and 44. So this comes out to be around 7 8 is a 56 minus 36, sorry, minus 36, that is minus 36 0. That's why you don't have to be too overconfident. 20. So this comes out to be 45 lambda, and this is determinant is 0, minus 0 is 0. This was your characteristic equation. This was your characteristic equation. Now come to this point. See, lambda cube, take lambda out. Sorry, take lambda out. Take lambda out. You have lambda minus 18 lambda. Lambda square minus 18 lambda plus 45, and you have a 0. Now this equation is very simple. 15 3s are 45. 15 3s are 45. Now check. One value of lambda is 0. The other will be 3. The other will be 15. Now they are all distinct eigenvalues. Distinct eigenvalues of linearly independent eigenvectors. Distinct eigenvalues. Eigenvalues. You have distinct eigenvalues. This you have. So now for each eigenvalue, I have to find a vector. For each eigenvalue, I have to find a eigenvector. Now for lambda equal to 0, now A minus lambda I x will be 0. A is what? A is your 8 minus 6, 2 minus 6, 7 minus 4, 2 minus 4 and 3. So what you do is that you take x1, x2, x3 and then you have 0, 0, 0. Now do one thing. I'll tell you two methods to solve this. Wait. See, you write, you cross multiply with this and this. 8x1 minus 6x2 plus 2x3 equal to 0 minus 6x1 plus 7x2 minus 4x3 equal to 0, 2x1 minus 4x2 plus 3x3 equal to 0. You solve any two equations. You solve any two equations. See how I solve it. See. Supposing I take these two equations, these two, I have written x1, then see, you hide the coefficient of this, hide the coefficient of, see, I'm taking these two equations. First, let me mark these two equations I'm taking. I am taking these two equations. You can take any two of your choice. For then I am hiding this. Now 7 threes are 21 I am writing. In this direction I am writing, that is minus 16. This will be plus 16 and in this direction is minus 16. Now when I will write x2, I'll put a minus sign. Wait, I'll remove this hidden parts. Yes, this hidden, sorry, this 6 has vanished. Wait. And then I'll remove this hidden part, this arrows, these arrows. Now I will do is that I'll hide the second column. Now I will multiply this way. I will multiply this coefficient with this and this coefficient with this. Now you will have minus 18, you will have minus 18, minus 18, and you will have plus 8. You will have minus 18 plus 8. Now you will rub all this. Wait, let me remove this line, this line, this line. Wait, this is x1. Now I will remove this line and okay, let it be there. Let this be there. Now you have x3. x3, you hide the third column. You hide the third column, multiply these two and multiply these two. The way you do in determinant. And 6 minus 24, no, this is plus 24. And minus 6 minus 4 is plus 24 and 2 and 7 is 14 minus 14. Now the next part is x1 by 5, x2 by, this will be minus 10, but there is a minus here, so plus 10. And this will be x3 will be again 10. So you divide by 5. So you have x1 by 1, x2 by 2, and x3 by 2. So the first vector for this is, x1 vector is 1, 2, 2. This is the way you write the vectors. Or you can do one thing. You copy this equation. Take this equation with you here. And do the row reduction and you can find it. You take this complete equation. See, I'm copying this equation. I'm showing you the other method. Here, paste this here. Now, remove this. Wait a minute. Wait a minute. Let me take it here. Yes. And let me write here x1. See, I got my vector actually. Let me mark it. I already got my vector, eigenvector. Now let me take this now. x1, x2, x3, and this is my 0, 0, 0. And I can do some row operations if you want. What I do is that I make this, I take R2, wait a minute, I take R1 is R1, R1 minus R plus R2. Or yes, I can do this, no problem. So this will become, I'm adding these two rows, this and this row I'm adding. This will become 2, this will become plus 1, this will become minus 2, and this is minus 6, 7, minus 4, and 2, minus 4, and 3. Now this is x1, x2, x3. You have your 0, 0, 0. Now you have, see, You do one thing. You multiply this with 3 and add to this. R2 is R2 plus 3 times R2 plus 3 times R3. See, now what happens is this becomes 2, 1, minus 2, and this is 2 minus 4 and 3. Now R2 minus 3 plus 6 is 0. 7 minus 12 is minus 5, and 4 minus 4 plus 9 is again minus 5. Sorry, plus 5. 4 plus 9. Minus 4 plus 9 is 5. And this you have x1, x2, x3. And you have your this as 0, 0, 0. Now you can do one more operation. Very simple. Do one thing. Divide this row by uh, divide this row. R2 is R2 minus 1 by 5 R2. So what you will get is 2, 1 minus 2, 0, 1 minus 1, 2 minus 4, 3. Now do one thing, x1, x2, x3, you have 0, 0, 0. Now you can make the R3 row, try to make this 0. R3 is R3 minus R1. So what you get is here, you get is 2, 1 minus 2, 0, 1 minus 1, and 2 minus 2. 2 minus 2 is 0, minus 4 minus 1 is minus 5, and 3 plus 2 is again 5. Now this is your x1, x2, x3, and you have your 0, 0, 0. Now you can do is that R3 is R3 plus 5R2. If you do this, you will get 2, 1, minus 2, 0, 1, minus 1, and 0, 0, 0. And then you will have x1, x2, x3, and this will be 0, 0, 0. Now see one thing, you have two equations now. 2x1 plus, you can do one thing, you can make them zeros, or you want to make them, see, 2x1 plus x2 minus 2x3 is equal to 0, and x2 minus x3 is 0. So from here I'll get x2 must be equal to x3. This condition must be satisfied. X2 must be equal to x3. If x2 and x3 are same, x2 and x3 are same, so I can take x2 and x3 has to be same. These two has to be same. That means I have to take, see how I take this as 2. See, I take x1 as 2. I take x2 and x3 has to be same. Na? So x2, if I take 1, that is, if I take x2 as 2, then x3 will be 2, 2, 2, 4. This will be 2. No, let me take x2 as, wait a minute. Let me, this is x2 minus x3. So x2 and x3 has to be same. So what I do is that, okay, I do one thing. See, this is, I think, did I make a mistake somewhere? This is minus 2. Okay, let me see whether my R1 was a mistake for me. R1 was R1 plus R2. 8 plus 8 minus 6 is 2, minus 6 plus 1, and 2 minus 4 minus 2. Exactly right. It's okay. Wait a minute. I got these two expressions. Wait. Somewhere I've gone wrong somewhere. Wait a minute. x2 minus 0, x1 plus x2 minus x3. x2 and x3 has to be same. So how do I make it 0? See, very simple. Wait a minute. Let me write the equation from here. So equation 1 becomes 2x1. Let us write it here. X3 and minus plus x3 and 2x3. So I get 2x1 minus x3 equal to 0. Right? So if I take x1 as 1 and x3 as 2, my job is done. See, my job is done, because if I take this, if I take, sorry, If I take this, this will become 2 into 1 minus 2 and 0, and this is basically x3, and then x2 will also be the same. So the vector will be 1 from here, and this 2 and this x2, they both will be 2. So 2, 2. You see, this is the way you can take it. But I think that method is easier in this case. This method is easier in this case. But I told you both the methods. This method is easier in this case. Now let's see. Now let's see for lambda equal to I did it for lambda 0. 3 and 15 are there. Now I'm going to do it a bit faster because I explained you everything here very clearly. For lambda equal to 3, a minus lambda I x is equal to 0. A is what? A is minus 8. A is minus 8. No, A is plus 8. Sorry. A is plus 8. A is plus 8 minus 6 and 2. And this is minus 6, 7 and minus 4. And this is 2, minus 4 and 3. Now see. Minus 3 times 1 0 0 0 1 0 0 0 1, and then you have your vector x1 x2 x3. Now this is going to be 0 0 0. Do one thing, always subtract this diagonal part. You have nothing to do with these elements. The remaining elements, you can forget all of them. You only have to consider the diagonal. Now see, I'm rubbing all these lines, all these dashes and everything. Now see, in the next step, I'm going to go for the next step. 8 minus 3 is 5. Keep the remaining same. Minus 6 will, 7 minus 3 will be 4. Minus 4 will be here. Now here you have what? 2 minus 4 and 0. This is you have got. Now you can make two equations the way you feel like. Or you can divide this by 2. You will get the way you want to do it. You want a row operation or a column operation. That's up to you. You want to use that or you want to use the method 1 or method 2, that's up to you. I'm writing down 5x1 minus 6x2 plus 2x3 equal to 0 minus 6x1 plus 4x2 minus 4x3 equal to 0, and then you have 2x1 minus 4x2 plus 0x3 equal to 0. I am taking the, let me say, if I take this two equation also, no problem. But I'm taking these two equations, this and this, and I am writing again. See, now see it very carefully. Let me mark which equations I'm taking. I'm taking these two equations. These two equations I'm taking. You can take this two also. You can take this two also. Any two you can take. Now see what I'm doing. X1, I am hiding this column, multiplying this and this. So this comes out to be 24 minus 8. Now you will now do one thing. Rub this, remove this line, remove this line. Now you will hide the second column. Now you will write minus x2, and then you will multiply. Wait a minute, let me change the color. You will multiply this with this with this, and this with this. So you have minus 20. You have minus 20 and plus 12. This is in bracket. Now you will rub this all. Wait, let me rub this line and this line. Now you will hide this. Now it is, wait a minute. This is now x3. This is x3. And then now you have to, wait, I didn't, yes. Now you have to do this, cross multiply these two. So what you get is 20 plus minus 12 again. So now let's do it. X1 is now 16. This gives me 16. This gives me x2 is equal to, this is minus 8, and this minus will give me plus 8, and this will give me again minus 16. This is giving me, I think I made a mistake somewhere. 6 6 are 36. Yes, I made a mistake here. This is 36. This is 36. And so this is going to give me x3 by minus 16. Now I divide by 8. I'll get x1 by 2. Then I'll get x2 by 1, and I'll get x3 by minus 2. So my vector would be So my vector would be, so my vector, so my vector would be x, vector x2 would be your 2, 1, minus 2. 2 for the first component, my 1 for the second component, and minus 2 for the third component. I hope you understood this. Let me rub them. And now I have to find for the third vector. I have to find for the third vector. I have to find for the third vector, for the third eigenvalue, sorry, for the third eigenvalue, that is 15. That is lambda equal to 15. Now see, you have a minus lambda. Every time you must write this formula, x equal to 0 and 8, and this is minus 6 and 2 and minus 6, 7 and minus 4, 2, minus 4, and you have 3. You have 3. This is what you have got. Fine. Now, now you have minus 15, 1, 0, 0, 0, 1, 0, 0, 0, 1. Then you write this way, x1, x to the components, x3, and this comes out to be 0, 0, 0. This is a matrix. Now just subtract the diagonal elements. See, 8 minus 15 will give me minus 7, minus 6, 2, minus 6, 7 minus 15 will give me minus 8 and minus 4, and this will be 2 minus 4, 3 minus minus 12 it will give, because I have to just subtract the diagonal element, wait a minute, the diagonal elements only in this case. I hope you have understood. Let me rub them. Yes. Now you have this with x1, x2, x3. So this is equal to 0, 0, 0. Now you will, if you do the calculation in this manner, wait a minute, let me drag down. Yes, you have got minus 7x1 minus 6x2 plus 2x3 equal to 0, minus 6x1 minus 8x2 minus 4x3 equal to 0, 2x1 minus 4x2 minus 12x3 is equal to 0. Now you can take any of the two equations. You may take these two equations and solve it, and you will get, now I'm not going to solve it, I'm giving you the direct answer. X1 by 2, you will get x2 by minus 2, and you will get x1, x3 by x3, x3 by 1. And how to solve it is your homework, how to solve. Now your third vector is 2, minus 2, and 1. Now you found these vectors, and you will have to, for lambda 0, you got x1, that is I think 1, 2, 2. For lambda equal to 3, you got the vector x2. You got the vector x2 as 2, 1, minus 2. This can also be written like this, 1, 2, 2, 2 transpose. This can be written as 2, 1, minus 2 transpose. And for lambda equal to 15, for lambda equal to 15, the vector was x3. This is basically 2, minus 2. Sorry, wait a minute. This is 2, minus 2 and 1, which can be written as 2, minus 2 and 1 whole transpose. Now here your answer ends. One interesting fact, in my previous video I did is, I showed you that A and P inverse AP have same eigenvalues. Now let me tell you what is this P. In my previous video, I told you that these two are this and this have the same eigenvalue. This P, see, P is invertible. I had told you that invertible. Invertible means determinant of P is not 0. But how will you get P? How to obtain P? How to obtain this P? Now see, P can be obtained from here. Suppose this was my question. Suppose this was my question itself. Where is the question? Here. Let's scroll up. Yes, this was my question. This was my question, supposing, and I wanted the P from here. So the P would be the eigenvectors that you obtained. See, that's why. See, your answer to the question paper in the question paper will finish here. Your answer to the question paper will finish here. This is extra knowledge. Extra knowledge. This is extra knowledge for you. Though this is not in your much use in your syllabus, but still, since you have seen this, then P is invertible. How to obtain P? Write P in this manner. Wait, let me write it clearly. P in this manner. What was your first vector? First vector was which one? You can write anyway. You can write this first. You can write this one first as the first column. This one is the first column, or this one is the first. That's your choice. But the vectors will come 1, 2, 2. This will be 1 in column manner only. 1, 2, 2. Then you had your then you had your 2, 1, minus 2. Then you had your 2, minus 2, and 1. This is the way you will finish. This is the way you will see P, and you can find P inverse very simple. Because this is an this P comes out from the eigenvectors. You obtain P from the eigenvectors. Wait, let me write it clearly. This P you obtain from the eigenvectors. Eigenvectors. You obtain your P. This is, though this is an extra information, that's why I've written extra knowledge or extra information. I just wanted to make you understand what this P is all about. I did the proof in the last video, but I wanted to explain you what P is all about. This is that P. Now we will see a question in which you will see the situation. Here you got distinct eigenvalues. Here you got distinct eigenvalues. Now let's understand something called, let us understand something called geometric algebraic multiplicity, multiplicity, and let us understand geometric multiplicity. Geometric multiplicity, multiplicity. Now I'll call it in short AM, and I'll call this short in GM. Now GM has a formula. GM is the order of the matrix. Remember, always you have square matrices. All matrices are square matrices. All are of the form A n cross n. Remember this. They are all square matrices. So let me wait a minute. Let me shift this formula a little down, and then now I will write it. What to write? Wait. Now I will write minus rank of A minus lambda I. This is how you will find the geometric multiplicity. This is the formula for finding out the geometric multiplicity. Very, very important formula. You need to remember it. Now, supposing, let us see a case situation. I'll explain you. Wait, if algebraic, see one important concept. One important concept is here. Geometric multiplicity is always less than equal to algebraic multiplicity. This is a known fact. You cannot change it anyway. This is a known fact. Now, what is the algebraic multiplicity and what is geometric multiplicity? If geometric multiplicity is strictly less than, that is, it's not equal to algebraic multiplicity for a certain value of lambda, that is the eigenvalue, then you need not proceed here. Then you stop. I'm not telling you a diagonalizable or anything, because that's not in your syllabus of GGSIPU. I'm just telling you this thing. You stop there. I'll do with an example and you will be very clear. Let's take one example. Now you have A as, you take a matrix A. You take a matrix question. You take a matrix A. To explain you the above concept, I'll tell you. I'll take two matrices and then I'll make you help you with the meaning of algebraic multiplicity and geometric multiplicity. This example will make things very clear for you. Now take A equal to, as my habit is to take A, minus 2, 2 and minus 3. Then you have 2, 1 and minus 6. Then you have minus 1, minus 2 and 0. This is what you have got. I am giving you, see, the trace A is Trace A is straight away lambda 1 plus lambda 2 plus lambda 3, and this is nothing but minus 1. Trace A is minus 1, and determinant A is lambda 1, lambda 2, and lambda 3. I'm putting a plus sign and a minus sign and a plus sign. I'll get this as, see, if I take this as this, so I'll get minus 1. I'll hide this last row and the first column. I'll get minus 12 plus 3, that is minus 9. I'll get minus 9 here. Then minus this one, and this minus will give me plus 2, and hide this third row, and the second column I'll get plus 12 and plus 6. Plus 12 and plus 6, I'll get 18. That is plus 9 plus 36, I'll get 45. Very simple. I'm not writing that formula, though I can write it down. You can now you will find this as your homework, minus this expression. How did I get this expression? Plus lambda square minus 2 lambda minus 45. You will find this characteristic equation as homework. You will find this. I'll not finding it now, because what I'll do, I'll just use this minus 1 and 45 to get the eigenvalues. See, 5 nines are 45. You know this. Let me put the rough sign. Yes. Then 5 comma 3 into 3. Now what I do is that I want minus 1. I put a minus sign. I put a minus sign. Now minus 6 plus 5, minus 6 plus 5 will give me minus 1, which I need here. Just a minute. Just a minute. Yes, here I get. Here it is. Yes, minus 1, and then I multiply 5 into minus 3, that is plus 9, in that is 45. So the lambda comes out to be minus 3, and 5. My purpose now is to explain you what is algebraic multiplicity and geometric multiplicity. Now see here in this example, lambda equal to 3, is appearing 2 times. You will see 3 2 times. So appearing 2 times. So here the algebraic multiplicity of lambda equal to minus 3 is 2. Algebraic multiplicity means how many times that value is occurring. How many times that value is occurring, that means algebraic multiplicity means how many times a certain value, oh sorry, wait a minute, how many times a certain value of lambda occurs, how many times a certain value of lambda occurs, how many times certain value of lambda occurs. This is what you mean by algebraic multiplicity. Now for lambda equal to 5, if you see, the algebraic multiplicity of lambda equal to 5 is just 1, because it is only here one time, and this is 2 times, therefore it is 2. Now we will have to find, so now geometric multiplicity of lambda equal to 5 will also be 1, because I told you gm is less than equal to am always. So if this is 1, this cannot be 0. This is 1, this cannot be 0, geometric multiplicity. So it has to be also be 1 here. But in case of 3, minus 3, we need to find using this formula that I told you here. See, I told you the formula here, this very red colored formula. This is what I need now. Now I will be finding the geometric multiplicity of lambda equal to minus 3. Now you see how to find the geometric multiplicity of lambda equal to minus 3. For lambda equal to minus 3, find this, a minus lambda I. Don't write an x here, Rahul, right now. Now you have what? What type of matrix you have got? Write that matrix. The matrix is minus 2, 2, minus 3, then you have 2, 1, minus 6, and then you have minus 1, 2, minus 2, and 0. Now you put minus 3, this is minus 3, and this minus is there. So this will become plus 3, and 1, 0, 0, 0, 1, 0, 0, 0, 1. Now do the subtraction in diagonal only. This will become minus 2 plus 3, this will become 1, 2, minus 3. 2 plus 4, and this will become minus 6. And this will become minus 1, minus 2, and plus 3. Now do one thing. This is what you got. Just a minute, let me rub this one. So now what you got for lambda equal to minus 3, for lambda, let me clear this. Just a minute. Yes, lambda equal to minus 3, you got a plus 3I as this, as this. Now use row operation straight away. R3 is R3 plus R1. Let me take some more page. Wait. Let me take some more. And then you use an operation. R2 is to be replaced with R2 minus 2R1. See what happens. See what happens now here. This remains 1, 2 minus 3. I'm using this operation. Minus 1 plus 1. This minus 1 plus 1 is 0. Minus 2 plus 2 is 0. 3 and minus 3 is 0. You got this? Now let's rub this. Let's rub this. Let's rub this. Let's rub this. Now you will do for this 2. 2 minus 2, 0. 4 minus 4, 0, because I'm doing it minus 2 here. See, minus 6 plus 6, this is 0. So now this is just, what is the rank of this? What is the rank? I've told you number of non-zero rows. Rank of A plus 3I is nothing but 1. And what is the order of this matrix? What is the order? 3 cross 3. Now I will show you what is GM. GM of lambda equal to minus 3 is the order of the matrix n, which was n there, minus the rank of A plus 3I in this case. So wait a minute, let me rub this, otherwise you will get. So you will get 3 minus 2, 1, and this is equal to 2. Here geometric multiplicity is equal to algebraic multiplicity of lambda equal to minus 3, which is basically 2. So here I'll get two independent eigenvectors. So I'll get two independent. So we get two linearly independent. Let me write it more clearly. Linearly independent eigenvectors, and we proceed further. Independent eigenvectors. Now half of my work is already over to find the eigenvectors. See, already I did this calculation. You can see I have already done this calculation without the x. And what I got, see here, come down, I got this. Let me tell you, I got this after the calculation. After using this row and column operation, I got this. I'll use this equation straight away, but by putting some x here. That is now see, for lambda equal to, I will not do that calculation two times. A minus lambda I x equal to 0. Now A you already know. You have done the subtraction, just copy that from there. You just copy this one. You copy this one. This comes out to be, let me rub all this and then I'll copy this. This one, and this. So I'll just copy this. Let me rub this one also. And now I'll just copy this from here. Because this is the same thing. Wait a minute. Wait a minute. Let me copy this from here. Yes. Just I'll copy this from here. And I will put it here so that things are easier for you. Now this has come. Let me drag this little bit here. Now with all the operations, here we have all the operations. Here we have all the operation x1, x2, x3, and with 0, 0, 0, and the same operation. R3 is R3 plus R1, and R2 is R2 minus 2R1. We get 1, 2, minus 3, 0, 0, 0. I'm doing it directly because I have already done it above. So I'll get x1, x2, x3. Now you got 0, 0, 0. Now see, this will be x1 plus 2x2 minus 3x3 is equal to 0. Now since geometric multiplicity is equal to algebraic multiplicity, therefore, what I'll do is that I'll put here, I can take the way I feel like. I'll take x equal to 1, I'll take x1 equal to 1, x2 equal to 1, and I'll take x3 equal to 1. No problem, because if I do this, what I'll get, 1 plus 2 minus 3, and this will give me 0. So my one vector, x2 vector, comes out to be 1, 1, 1. This is one vector. Now suppose I want to find the next vector, but I'll use the same equation. What I do is that I take this as I take x1 as minus 2, I take x2 as 1, and I take x3 as 0. So what do I get? Minus 2 plus 2 into 1 and minus 3 into 0. So I get minus 2 plus 2 minus 0 is again a 0. So my next vector comes out to be minus 2, 1, 0. You can take any number of your choice. See, they are linearly independent but not unique. Now, with this, I have made you understand the concept of geometric multiplicity and algebraic multiplicity. Now, the third case that comes in picture is, now see the third case which will come in picture, that is, I'll show you one in this. Wait a minute. Let me take that a question. Let me take a question. Question is A, habit of taking A's only. 210 0, 2, 1 and 0, 0, 2. Here it is very simple. Trace of A. Trace of A is again lambda 1 plus lambda 2 plus lambda 3. And then you get equal to 4 and 4, 2 to 4 and 6, 2, 2 plus 2, 2 plus 2, that is 2 plus 2 plus 2 and you get 6. And determinant of A is lambda 1, lambda 2 and lambda 3. You expand it in this manner. You expand it in this manner. So you get, wait a minute, you get, wait, let me rub this one and let me write it clearly. 3, this you will get 2 2s are 4, 4 2s are 8. You will get 8. This you will get as 8. Fine. Now let me rub these two lines, this line and this line. Now let me rub them also. Yes. Now you will write down the characteristic equation yourself. I am not going to do it anymore now. That is your homework. You write the characteristic equation. That will be something like, let's say, lambda cube and all that stuff you will write. I'm not going to write it. I'm just going to find out directly without writing the characteristic equation. The characteristic equation is for your homework. Let me still tell you. The characteristic equation is lambda cube. Then it is, let me give you the expression itself so that you can do it as your homework. Lambda minus 2 whole cube. So you will get lambda is equal to 2, 2, 2. Here you see one thing. Here you see one thing. The algebraic multiplicity of lambda equal to 2 is 3 because 2 is occurring 1 time, 2 time, 3 time. Now let us see geometric multiplicity. Geometric multiplicity, I need to use the formula n minus rank of a minus 2i. The formula. This is the formula. Now what I will do is that a minus 2i. What is my a? A is for lambda equal to 2. A minus 2i. I'll not put the x. What I'll do is that I write this. A is 210 0201. Sorry. And this is 002 minus 2. Sorry, this has become very big 2. Wait. This is 2 and then this is 100 010 001. Now I'll do the subtraction and then you will get, wait, you will get this as 0 1 0 0 0 1 and you will get 0 0 0. Here the rank of a minus 2i is equal to 2. Sorry, let me write it properly. Here the rank of a minus is 2. Now let us find the geometric multiplicity using this formula. So let me write it down. So geometric multiplicity, the order of the matrix is 3 minus rank of a minus 2i, that is nothing but 3 minus 2, that is 1. So algebraic multiplicity, geometric multiplicity of lambda equal to 2 is not equal to algebraic multiplicity of lambda equal to 2. Why? Because the geometric multiplicity of lambda 2 is 1 and algebraic multiplicity of lambda 2 I just found out to be 3. Now I will only get, because there is geometric multiplicity is only 1, I will only get one linearly independent eigenvector. I will only get, see, what is the vector I'll get? For lambda equal to 2, I just have to write a minus lambda I x equal to 0. I already have this equation here. I already have this calculation I already have here. See this calculation. This calculation I have already have here. Till this, I mean to say this all calculation. This calculation and then the resultant of this calculation I have already here. So I just have to copy this. I'll just copy this. This is nothing but this is I'm just copying it 0 1 0 0 0 1, and then you have 0 0 0, and then you have x1 x2 x3, and then you have 0 0 0. From here if you see, this when multiplied with this will give me 0 x1 plus 1 x2 plus 0 x3 equal to 0, implies x2 is always 0, always, because of this point. And with this second equation, I'll get 0x1, 0x2 plus 1x3 is 0, which will always give me x3 equal to 0. x1 is arbitrary, arbitrary. You can take any value as you feel. So my first vector will be 1, 0, 0. The other two vectors, because you need three vectors, because there are three eigenvalues, x2 will be some multiple k times x1, and x3 will be some multiple, let's say k1, this is k, this is k1 x, the first vector. So I will get, so only one linearly independent, only one linearly independent vector in this case. I hope with this you have understood the concept of this um, linearly independent vectors and how to find eigenvalues and eigenvectors. Let me take a question A. The matrix A is your 2, -1, 1, and you have your -1, 2, -1, and then you have 1, -1, and 2. Now trace A is lambda 1 plus lambda 2 plus lambda 3, and this is equal to your trace is equal to 6, 2 plus 2 plus 2, let me write 2 plus 2 plus 2. Now determinant A, that is lambda 1, lambda 2 and lambda 3, this comes out to be around, let me find out the determinant of this matrix straight away from here. This is 2, I'm doing it directly, 4 minus 1 plus 1, because this is the minus sign here, therefore it is plus 1 there. Then we have -2 and +1, -2, wait, -2 and -2, wait, it's -2, I wrote 2 by mistake, it's -2 plus 1, and then you have your plus 1, and then you have 1 minus 2. So your determinant A is 2, 3, 4 minus 1, then plus 1, minus 1, and then plus 1 and minus 1. This is 6 minus 1 minus 1, and this is nothing but 4. This is capital 4. Now you see one thing, you get a 6 here, you get a 4 here. Now I need to find the characteristic equation. So A11, let me find A11. A11 would be directly, it will be 4 minus 1, that is 3. I'm doing it directly now. A22, it will be, now you have to hide this. This is the way you hide this, and then you get 4 minus 1. Again, this is 3. Again, this is 3. And then you have it, let me rub this line, and then now I hide this line and this line the way I used to find minus. Now you will have A33. A33 is 4 minus 1. That is again 3. You get, wait a minute, you get 3 here. Let me rub these lines also simultaneously. You get 3. Now lambda cube minus this 6 lambda square, then 3 plus 3 plus 3 plus 6 lambda minus determinant minus 4 equal to 0. This is the characteristic equation. Now I have to show that this equation is satisfied by the matrix. Now I have to find A square. That means A into A. That means I have to write this 2 times. This is 2 times 2, minus 1, 1, then again minus 1, 2, and we have minus 1, then you have 1, minus 1, and you have got 2. Again, you write 2, minus 1, 1, minus 1, 2, minus 1, 1, minus 1, 2. I'm not going to show you the multiplication. I'm giving you the answer right away. So this is 4 plus 1, 5 plus 1, 6. This is 6. Now this is minus 2, minus 4 and plus 1, that is minus 5. Now this is now 2 plus 1, that is 3 and 2, 5. I get 5 here. I hope you are understanding. I'm doing this way and this way, each row and column wise. You know how to multiply now matrices. Now I'm doing this. Minus 1 you will get here is minus 2, minus 2, minus 2, minus 5, minus 4, and you will get minus 5. You will get minus 5 here. You will get a 6 here, and similarly you will get minus 5. Now you will get here as 1, 2, 2, 4, my plus 1, that is 2, and 1, 3, and then 2, that is 5. Similarly, minus 5 here, and then you will have 1 plus 1, 2, and 2, 2, 4, and that is 6. 4 and 2, 6. So a square you have obtained. Now you obtained a cube. A cube is nothing but a cube. A cube is nothing but a square dot a square dot a, that is your 6 minus 5, 5 minus 5, 6 minus 5, and then 5 minus 5 and 6. Now you have this 1, 2, 1, minus 1, 1, 1 minus 1, 2, minus 1, 1 minus 1, and 2. What you obtain is, see, 6 for 2s are 12 plus 5, that is 12 plus 5 is 17, 17 plus 5 is 22. Similarly, you will obtain the rest minus 21. I'm giving you the answer directly. You have to do the calculation on your own. That is your homework. 22. I've done a lot of multiplications till now. Now, by now, you should have been accustomed to all this now. Minus 21, and then you have 22. Now, this you have got. Now, we will put the values of this in this equation, in this characteristic equation. Where is my characteristic equation? Let me mark it properly. My characteristic equation is this. This is my characteristic equation. In this characteristic equation, I will put all my values. See, now it will become, wait, now it will become a cube minus 6a square plus 9a minus, now I will not keep 4, I will put an identity matrix of order 3 equals 3. Now you see a cube is how much? A cube is 22 minus 21, 21 minus 21, 22 minus 21. Then you have is your 21 minus 21 and 22. Then you have with 6a square. 6a square means you need to put minus 6 here and a square. What is a square? You can see it is 6 minus 5 and 5. And then you have your minus 5, 6 and minus 5, and then you have your 5 minus 5 and 6 plus 9 into this whole matrix. 2 minus 1, 1, minus 1, 2, 1, 1 minus 1, 2, then minus 4 into the identity matrix 1, 0, 0, 0, 1, 0, 0, 0, 1. This matrix, I have to show this is 0, 0, 0. See how? See now this is your now this is 22 minus 36. 22 minus 36 plus 18 and minus 4. See how it is. 22 minus 36 plus 18 minus 4. Then you have your minus 21 minus plus 30, then you have your minus 9 and 0, minus 0, then you have your 21 minus 30 plus 9 minus 0, you have this one, and then you have minus 21 plus 6 plus 30, because minus 6 and minus 5 is plus 30, and then you have your minus 9 and minus 0, then you have your 22 minus 36 plus 18 minus 4, then you have your minus 21 plus 30, and then you have minus 9 and minus 0. The last is 21 minus 30, 21 it is, sorry, let me rewrite it. 21 it is. This is 21 minus 30 plus 9 minus 0. Then it is minus 21 plus 30 plus 9 minus 0. Then you have 22 minus 30 plus 18, 18 minus 4. So you get the answer as, now you get the answer as, this whole thing becomes 0, 0, 0, 0, 0, 0, 0, 0, 0. So Cayley, Hamilton, Cayley, Hamilton theorem, theorem is verified. This first part of the question is this. Next part they are asking you, what is the value of a to the power of 6 minus 6a to the power of 5, then you have plus 9a to the power of 4 minus 2a cube 2a cube minus 12a square plus 23a minus 9i. They are asking you this value. They are asking you this value. What is the value of this? Do not go for multiplying a 6 times. Don't do that. You have your characteristic equation. You have your characteristic equation as a cube minus 6a square plus 9a minus 4i. This equation you have, and this is equal to 0. You just now saw it. Now what you do is that you have already seen in class 8th and 9th maybe, that whatever equation you have, suppose you have x square plus x plus 1 and you have divided this type of equation, x to the power of 4 x square something like this, x cube plus x plus something like this. You have taken x square, then x square plus x cube. These type of problems you have done in smaller classes. So similarly you will do it here. What you will do it here is, I'm now rubbing this whole portion. Similarly, what you have done in this in class 8, you will consider this as one algebraic expression. Sorry, you will consider this as one algebraic expression. You will consider this as the other algebraic expression. Now you see what I do. I take this as a cube. I write it here. Minus 6a square plus 9a minus 4i. And I do this division here only. Now I have a6. I have a6 minus 6a5 plus 9a4 minus 9a4 minus 2a cube minus 12a square plus a square it is 23a and minus 9i. Let me write the thing more clearly. Wait a minute. This is a square. This is a. Let me write it clearly. A square and this is a. Now a6. So you write here a cube. A cube. A cube. This will become a6. This will become 6a5. This will become 9a4. This will become minus 4a cube. Now this is going to go minus plus minus plus. They all will cancel out. You will have here is 2a cube minus 12a square plus 23a minus 9i. Now with a square plus a square plus 2a square rather 2a square. So you will write 2a cube minus 12a square, 9 2s are 18 plus 18a minus a square. Wait a minute, I think, wait a minute. This is 2a, 2a it will be, sorry. This will be 2a, sorry. And yes, 2a, a6a cube, exactly. With this is gone, a cube has come here. So now you will have to write is, this is as your 2, a cube plus 2, not a also, sorry, only 2. So you will not write 2 like this, you will put an identity. This will become 2a cube, 12a square, 18a minus 8i. This is the way it is. Now this is minus, this is plus, this is minus, and this is plus. This cancels out, this cancels out. This comes out to be around 5a. 5a plus minus I, 5a minus I. So this is your remainder, this is your quotient, this is your this is your divisor, and this is your dividend. And already in class 10th, you know this formula. You know this formula in class 10th. See, if A divides B, and this is Q, quotient, and this is the remainder, then this B can be written as A cube plus R, where R is in between greater than 0 but less than greater than equal to 0, or but exactly less than, sorry, exactly less than, exactly less than this A. This formula you know in class. This is basically that only. So let us now write down this expression. Let us now write down this expression in this manner. Wait, where is it? Here it is. This expression, this whole expression, as in this manner. See how I write it. Let me now rub this portion so that we get space. Let me now rub this portion. Now you know what to do. Wait. Let me now rub this completely. Now your this thing becomes your a6. Let me write a6 minus 6 a to the power of 5 plus 9 a to the power of 4 minus 2a cube plus 12a square plus 23a minus 9I is equal to your this a cube. This was your characteristic equation, 6a square plus 9a minus 9a minus 4I into a square plus 2I, and then your remainder is 5a minus I. This is your remainder. This is your remainder. This is your dividend. This is your dividend. Let me write it down. Dividend. This is your divisor. This is your divisor. Divisor. This is your quotient. This is your quotient, and this is your remainder. Remainder. This is your remainder. Now, let me write it clearly. Wait, remainder. Remainder. This is your remainder. Now, this quantity is always 0. Why? You are seeing this here. We just proved it also. This quantity is 0. You can see this. This quantity, whole quantity is 0. You can see this. So, what I'll do is that I'll write this as this is equal to 0 into a square plus 2I plus 5a minus I. Very simple now. So what am I left with? 5a minus I. Now write down 5a. What is a? A is 2 minus 1, 1, minus 1, 2, minus 1, sorry, plus 1, minus 1, exactly, minus 1. And then we have 1, minus 1, and 2. And then you have your 1, 0, 0, 0, 1, 0, 0, 0, 1. Now you will do this calculation. So you will have 10 minus 1, that is 9. 10 minus 1, that is your this is 5 to the 10 minus 1, that is 9. Rest all will remain as it is. This will be minus 5. And then this is 10 minus 1, again 9. And this will be minus 5. Sorry, I made a mistake. 5 is multiplied everywhere. 5 is multiplied everywhere. So minus 5 and 5. And this will become 5 minus 5 and 10 and then 1, 9. So this will be your final value. I'll give you this. I hope now you understood how to tackle this type of question. And I'll give you one more question. You can try on your own. I'll just give you the final answer. And this should match. Let me give you the question. The question is A equal to 2, 1, 1, 0, 1, 0, 1, 1, 2. First part is verify Cayley-Hamilton theorem. Cayley-Hamilton theorem, and find value of find value of this is a to the power of 8 minus 5 to the power 7 to the power of 5. Sorry, extremely sorry. This is a to the power of 7. Then you have plus 7 a to the power of 6. Then you have minus 3 a to the power of 5 plus a to the power of 4 minus 5 a cube, and then you have plus 8 a square minus 2a plus 1. If this is a to the power of 8 minus 5 to the power of 7 plus 7 a to the power of 6 minus 3 a to the power of 5 plus a to the power of 4 minus 5 a cube plus 8 a square minus 2a plus 1. And the solution to this is the value of this value of this is, I'm giving you the answer here, I'm giving you the answer here, that is 855,030 and 558. You need to do this as your homework, and I hope I have been able to make you understand both the Cayley-Hamilton and the eigenvalue and eigenvectors.